Next question is question number 20. Question number 20 is so that the right circular cylinder of given surface and maximum volume is such that its height is equal to the diameter of the base. We have a right circular cylinder whose radius is r and height be h. So first of all, let radius of the right circular cylinder be r and height be h. Radius be, let question number 20, let radius is equal to r and height is equal to h. Now given surface area means surface area of this cylinder, this right circular cylinder is given. So S, we know that surface area of a right circular cylinder is 2 pi r square plus 2 pi rh. 2 pi rh is the curved surface area of the cylinder and 2 pi r square is area of the top plus area of the base. So 2 pi r square plus 2 pi rh. Now S is equal to 2 pi r square. We have to find the value of h in terms of s and r. So we can write s minus 2 pi r square is equal to 2 pi r h. 2 pi r h. Now h is equal to implies that h is equal to s minus 2 pi r square by 2 pi r. 2 pi r. H, value of h is s minus 2 pi r square by 2 pi r. Now volume of the right circular cylinder. We have to maximize the volume of this right circular cylinder and we know that volume of right circular cylinder is pi r square h. Now put the value of h. So we get pi r square. Value of h is s minus 2 pi r square by 2 pi r. This is the value of h. Now after simplification we get pi cancel and one r is also cancel. So we have sr by 2, first term is sr by 2. Here one r is left, so sr by 2 minus 2 pi r cube, 2 cancel, 2 pi r cube by 2. So 2 is cancelled, pi r cube. Sorry, 2 pi r cube. Now, for maximizing this function, we have to differentiate this function with respect to r, as volume is a function of r. So, for critical point, we have to differentiate this function with respect to r. We get dv by dr is equal to sr by 2, derivative of r is 1, so s by 2 minus here pi r cube, derivative of pi r cube is 3 pi r square. This is the derivative of v with respect to x, with respect to r. Now for critical point, put this value is equal to 0 for critical point. For critical point, dv by dr is 0. dv by dr is 0, that is s by 2 minus 3 pi r square is equal to 0, implies that s is equal to 6 pi r square. Value of s is 6 pi r square. After simplification we get s is equal to 6 pi r square. Now we know that s, value of s is 2 pi r square plus 2 pi r h. So again continue value of s. Now put the value of s, that is s is equal to 2 pi r square plus 2 pi r h is equal to 6 pi r square. Here s is equal to 6 pi r square and value of s means surface area of this right circular cylinder, and we know that surface area of right circular cylinder is 2 pi r square plus 2 pi r h. After simplification we get 2 pi r h, 2 pi r h is equal to 6 pi r square minus 2 pi r square, that is 4 pi r square. So h is equal to 4 pi r square by 2 pi r. Pi cancel, 2 2s are 4 r, that is 2r. Value of h is 2r, that is value of h is equal to diameter r. 2r is the diameter of this right circular cylinder. Now we want to show that this value gives the maximum value of the volume of this right circular cylinder. So dV, again differentiate dV by dr with respect to r, we get, now differentiate this function with respect to r, we get d2v by dr square is equal to s by 2, this is constant, so s by 2 is equal to 0, minus 6 pi r. Derivative of 3 pi r square is 6 pi r. 6 pi r, and 6 pi r is less than 0 for all value of r. R is a positive quantity as radius is always positive. So 6 minus 6 pi r is less than 0. Pi is positive, r is positive, 6 is positive. So all these quantity positive, but negative sign gives the value is less than 0. So d2 by dr square at h is equal to 2r gives the maximum value of this right circular cylinder, maximum volume. So we can prove that height is equal to diameter of the right circular cylinder. So for maximum volume of this right circular cylinder, when height is equal to diameter.